Okay, I think it's fixed now.
Right. How's it going? How are you doing?
Doing good. Now that I figured out how my computer works, apparently. How about yourself?
Yeah. Pretty good. I actually just closed like a Game of Thrones tab just so I wouldn't accidentally hit the play button like during the. So yeah, doing pretty good.
Good, good. Yeah. Apparently, I needed to do the same.
Yeah. Um, do you want to start by? I guess we could start by introducing ourselves.
Yeah, yeah. I can go first if you'd like.
Yeah, of course,
Yeah,
of
my
course.
name's Chris. I graduated, I guess, just 2 and a bit years ago now, just after the pandemic. So in 2020. I did engineering science at the University of Toronto, major in robotics, then went on to do the AI residency at Google and have since stayed on as a researcher.
Yeah.
So yeah, my role is basically I focus on doing privacy preserving machine learning research, which focuses a lot on both driving like new innovation and like technologies in that space, but then also bringing them into production so that we can use them for our products.
Oh, sounds good. My name is, I just blinked out on my name for a second. My name is Kevin. I am a 2021 Schulich Leader at the University of Alberta. And I'm from Calgary. I went to high school in Calgary, and now I'm living 3 hours north of Calgary in Edmonton.
Mm.
Yeah. And I believe we both have a shared interest in AI, which is hence this conversation. Um,
Yes.
I
So,
was,
actually, a quick question: is
yeah,
Edmonton where the University of Calgary is, or is that
oh,
just where you are right now?
Edmonton. I go to the University of Alberta is in
Oh,
Edmonton. The
sorry.
University of Calgary is in Calgary.
Oh, I understand now. Gotcha. Okay,
Yeah,
I was confused.
no, it's all good. And I was actually you actually answered a couple of the first questions I had, like for example, where you went to school, your background. So, I guess I could skip those. How did you get interested in AI? Because I actually have many people here at least that are interested in the domain. So, like, how did you personally get interested and involved in AI?
Yeah. So I kind of had a bit of roundabout path. Like I was interested in biology for quite some time, and then in like management consulting and business. But then I guess kind of through engineering, you get exposed to AI for sure, because it's one of the main topics that they'll talk about. And so I'd heard about it through a lot of my courses. And then I was offered a position at Intel as an intern there for a year to explore doing research in AI and also kind of the productionizing aspect as well. So that was my first chance getting to really play with a system and do research in that way. And that is kind of what started my journey to where I am now because I just really love that experience of being able to like figure out what it is you want to study, figure out what experiments it is that you need to run to prove a point, and then be able to like go publish a paper off of the work that you did was all very exciting to me. And then after that, I started doing research with the Clever Hans Lab, which is at the University of Toronto, which was like my first real opportunity to like dive headfirst into like state of the art research.
It's interesting that you mentioned Intel actually, because um, normally my association of like Intel's like a very hardware-ish company, like just working on chips. So can you tell me more about like how you got involved within AI within the hardware company and what exactly AI within like the hardware industry looks like?
Yeah, there's actually a lot of places where AI is used in hardware. I would say I got pretty lucky in my particular circumstance, which was because I was on like a tools and testings team, and so they were looking at AI to enhance some of the tools that they provide. One of them was like a testing infrastructure, and so they were looking at using, and this was my first ever paper, was using deep learning to be able to figure out who we should assign bugs to in a testing infrastructure when you, especially when you have automated bugs that are generated from like, these errors have led to some sort of issue in our system via these tests. Who should take a look at these?
Yeah.
So that was the sort of project that we were working on there. But there are lots of other like high level topics that are very useful. For instance, like in data centers, figuring out which jobs should be scheduled is also partly an AI task. And then figuring out like cooling systems and all of that as well. Like I think there's like some system that like DeepMind worked on for Google that like optimized like how scheduling and all that stuff was done in data centers.
Hmm. So it's more related to the management aspect of the companies or like within teams and on the subtasks they're working on?
Kind of, yeah. I guess in this case, I guess if you think about it broadly, like AI is basically decision making. So there are lots of places where you could try to throw in like a decision making black box for you to try and optimize something. Especially in a lot of cases, like at Intel, for instance, there are a lot of systems that are built off of like very rudimentary logic flows, like basically every company. And so trying to figure out how to like create a logic flow that is more optimized and learned based off of the system was something that, whoa, that was cool.
The room I'm in that has automatic lighting. So just give me a second, because I wasn't
Yeah, no
aware it
worries.
turned on. Yeah. All right, there we go. That might happen again a couple of times. I'm not sure.
Yeah,
I
no
guess
worries.
let's move around a little bit. But sorry, go on.
Yeah, so there's a lot of places where you can stick that in. For instance, like there are other companies nowadays that explore like how we can do AI for security and like camera systems, for instance. Like you would think, oh, these just take video in case we ever need it for like some incidents to happen, but you can actually improve a lot of the security aspect of it as well by like letting security guards know which areas they should be patrolling because something might be going on at that particular period of time, or even just like only saving relevant areas of video because like so much of it probably is just blank screens. So
Yeah.
there's lots of areas where AI has like a very well-defined task that it can work on.
Yeah, those were all very interesting applications of AI. You said you started at Intel, but where was the second place you worked at again? I believe you said some
Mm.
institute in Toronto.
Yeah. So that was I basically spent a year-long internship at Intel, and then after returning back to my undergrad studies, we had like an undergraduate thesis. So I did my thesis with the Clever Hans Lab, which is led by Professor Nicolas Paperneau. It's associated with both Vector Institute and U of T, but it's basically just like an AI research lab.
Yeah.
And so that was my first like research associate position with that lab, and where I really dove into doing like privacy preserving machine learning research.
If I may ask, how did you get into that position? Because, I mean, I'm in second year currently, but even in high school, I was somewhat curious about AI research and how to get involved within that. So, for both high school students and new university students, like, what is the path into university AI research?
I think it's actually a lot less daunting than it's made out to be. In my case, I had made the connection with him through another project I was working on at a different company. And so I had reached out and he was interested in taking me on. But I had done a few other, like, not in AI, like research positions as well. And I know lots of other people who have gone a different route, which is just like the cold emailing approach or the cold calling approach. And it's worked really, really well in a lot of cases. I mean, you have to be willing to be okay with being rejected in the sense that a lot of profs are too busy and like A, might not even see the email, or B, just might not have the bandwidth and not respond. But a lot of people, especially myself included, when I was deciding if I would want to become a professor one day, when there's a good proportion of professors that do it because they want to help the next generation. So you just need to be lucky enough to hit those profs, and also like find profs that have bandwidth. And like even if you have less experience coming into it, chances are there'll be someone who will be willing to do that mentorship role. And it might be a bit more of a grind, so to say, at the beginning. Like it might be hard work, or it might be a lot of new topics that you're unfamiliar with. But if you're really, really interested, it's quite feasible to find a role somewhere.
And would you say that you should have a specific domain of interest within AI going in, or is it a bit more flexible when you're
Mm.
looking around for research positions?
I think it's a lot easier if you have a specific interest because it means that the prof can, like normally how a lab will work is they'll have like a bunch of ideas that are floating around on their back burner. Like I keep a list of like all the ideas I've ever thought of for projects. And typically a lot of researchers do that as well. And profs will allocate those to different students based off of their interests. So knowing what you are interested in upfront really helps smoothen that process, but you don't have to. Like one of my first AI research positions before that one was like a very short one with another lab, and they had just kind of been exploring, I believe it was AI for a lot of different things in the chemistry space, but my project was molecular discovery. And so they just like had this project that seemed like a good fit. And they, proposed that one along with a few others. And then at the end of the day, I got to pick the ones that I wanted to work on. So um, you don't really have to have something going right into it, but it helps.
Okay, yeah, because right now that's actually one of the things I've been thinking about a lot lately. Currently, I'm trying to focus most of my learning on natural language processing, but
Mm.
there's also a lot of other very interesting domains within AI. So I've sort of been on the table with do I focus specifically on NLP, or should I be dipping my hand in all of the cookie jars, trying to like get as much experience in as many domains as possible before?
Yeah, I think early on, it's more important to find what you're interested in because especially within research, it can be quite a lot of work at the beginning when you're like a very junior researcher because there's just so many things that you don't even know, that you A, don't know, and then B, don't even know to look out for, like all of the unknowns, so to say. And early on, that can mean that it's a lot of work to become familiar with a lot of things. And so it's good to kind of spread your weight between a lot of different areas that you might be interested in before you really start deciding to focus on one particular specialization. At some point, I think it's important to start specializing because as a researcher, you want to be known for like a person that is the expert in something, and you can only be an expert in so many things. Especially, you know, like not necessarily by age, but just like by number of years spent on something. There's only so many things you can be an expert on until you know you've done everything at some point, and then you're like an expert in a lot of things. But it takes time to get there. So that's one point to make there. The second is also, I would say you definitely have to apply to labs that have projects in the space you're interested in. Like some labs are just NLU labs or NLP labs. Some labs are just like security labs. Some labs are like statistical learning labs. And so you won't be able to find like very many other projects on the outskirts. And it might not even be good to do that research with the lab because they might not have the skill set to help you succeed in your project while you're there with them. So if you have a few different interests, I would say like find the best profs or like a group of profs in each one, and then apply to a bunch of them, see which ones you know are interested in you, and then you can kind of decide which one you want to focus on for that project. But once you take on a project, I think it's important to really focus on that one and you know take it from beginning to end and like have a very successful outcome. Because if you try to do too many at the same time, then A, your outcome might not be as good, and B, your learning might be spread too thin for you to really like truly understand the work that you did.
It's fair enough. You've mentioned how projects, which I'm guessing are a very, very big part of research, but I'm wondering what those projects actually look like. So, for example, if I was working with either a professor at a lab or maybe even in industry, what does your average day within a research environment look like, and the work that you do in that environment?
I guess it depends on academia versus private institutions, but you can roughly think of it as like an 80-20 split between like core tasks and then like miscellaneous stuff that you have to do. So like for instance, in an academic lab, it could be like helping out with grant applications if you're like a more senior member, or other tooling that the lab tries to do to make things more efficient. You know, in a corporation, it might be like some tasks that you have to do to drive revenue or what have you. But for the 80% of your core work, uh, depends on how you like to structure your day. I think earlier on, it's really good to focus on a single project. And your day will focus a lot on A, thinking about what the story is for the project that you're working on. B, thinking about what the core statements are that you want to make. And then C, thinking about how you can prove those statements via either like some theoretical claims or some empirical claims. I would say those are like the three major things. And then day to day, that can involve like a lot of coding, for instance, to code up experiments, run them, monitor them, see if the outcomes are as you know the claims that you want to make, or if they're not, you know, rethinking how you want to shape those experiments or shape the claims that you want to make based off of what you're seeing theoretically or empirically.
I believe I may have already touched on this a little bit, but one of the things I was also wondering coming in was just how would you recommend we first break into AI? Because from what I've seen, like, and especially from your description of just the research environment, research is a fantastic way to gain experience. But outside of like working, let's say, in a lab, how would you recommend a student or anyone else looking to get involved in the industry build experience such that they could either get those research positions or in industry, or just become technically competent if that's their goal too?
Yeah, I guess it depends on what the outcome it is you're looking for. If it's to work in the AI space and maybe bring those things to product, I would say really useful things are just working on like side projects where you integrate AI into like some sort of system, like for instance, building robots that have like object classification abilities, and then maybe some like control flow to like make them walk around in some pathway. like small projects like that are a really good way to understand systems that are built on AI and that will leverage AI. And that can be really good for like machine learning engineering roles at like startup companies or big companies. If you're interested in doing the research pathway, then I would say those are still good things to do. But the most important thing I would say is to get research experience under your belt by taking on small tasks at the lab at first, if that's the easiest thing, or if you like get a full research position with them, then that's like the golden star sort of thing to do, because a lot of what a professor will look for down the road for either a PhD or for like a research associate position
Yeah.
is, no worries, is having a student who can drive a research project to success, meaning like to publication and beyond.
Okay, that definitely makes sense.
And in terms of, I guess, that latter pathway, because you had asked about actionable things to do,
Yeah.
I think really it just comes down to having the confidence to email profs. I feel like in my experience from the people I've chatted with, there are quite a lot of positions out there, just not enough people like, looking for them in a sense. And obviously it comes down to like the right profs getting the emails and there being a fit between the two people. So preparing yourself to have the best shot can be like doing really well in courses, taking the right sorts of courses to like give yourself the skill set. And then just from there, it's like once you've got that, it's emailing enough profs that you get the lucky one that will take you on. And then that sort of starts the snowball effect of, the second prof will take you because of your first experience, etc.
Um, I understand that you're currently researching at Google Brain, you said.
Yep.
How do you find that as opposed to, I guess, university-centered research? Do you?
Um, Hey, sorry, you were going to say something?
Oh, no, no, no. I was just gonna say, not necessarily which you personally prefer, but what are the likes and dislikes for each path?
Yeah. I had read a good tweet by a fellow researcher once that I really vibe with, which was depending on what pathway you pick, the BS comes in different forms. So if you go down like the academic pathway, then typically a lot of that will come up front. And then later on, like say once you become a prof and you get tenure, you can basically roam free.
Yeah.
In industry, it's kind of more consistent and maybe even gets worse the higher up you get because you'll have more responsibilities. So if you're really passionate about being able to explore anything that you really want, then academia is the perfect place to be, because there's a lot of room to do things that have impact in the very immediate future, but also a lot of room to explore things that might not have impact for like 10, 20 years down the road, just because of the way academia is set up. In industry, one of the biggest things is we typically focus on things that we can believe will have impact at some point. Not necessarily in the very short term, like we definitely have lots of long-term projects, but we scope out long-term projects with a lot more care to see that they'll have, at some point in the future, some way of turning a revenue or improving something related to the company. Otherwise, there'd be no point in doing it.
So there's less, I guess, range to the research you can do. It's just more centered around product development.
In a sense, yeah. I wouldn't necessarily say directly tied to product development. For instance, there's a lot of just like, for instance, Google has a huge like optimization team for machine learning research. And loosely speaking, or directly speaking, sorry, it has no direct product ties, but loosely speaking, it impacts a lot of products, because being able to improve our ability to optimize machine learning systems means that we can directly leverage that in a lot of different products. And so that's why that team focuses a lot on that work. And it's pretty easy to show via either a short or long-term project that any sort of improvement would lead to downstream impact. But that's still the consideration, is trying to figure out how to showcase that your work will have impact.
Within. Okay. Um, Kind of building up on the last thing that you mentioned. This is something I've been thinking about a lot, actually over reading week, which my school had just last week.
Ah,
It does seem that even within industry, most of AI is contained within the realm of research. And I was wondering, like with a more like product first type mindset, what sort of opportunities exist within AI for something like that?
I would say arguably more of the rules are within product, actually.
Hmm.
Um, Typically, I would say you need fewer researchers to be able to um, own that sort of work than you do like the number of people to like build systems around AI and think about how to integrate those with product. So I think having a product first mindset opens a bit more doors in that sense. In terms of things that will be beneficial, I would say you don't really need to have like a 100% super in-depth understanding of AI systems to have the product first mindset. I would say what's more important is understanding the impact of a system and understanding its limits and its capabilities more so than how it's actually implemented or how or what will be coming in, say, like the next 5 years per se.
By the way, do you have any experience working within a more startup environment? Because now that you mentioned, like a lot of what you've mentioned has revolved around the scope of projects. And I understand that the scope of projects is different within startup versus within big tech. So I was wondering how that plays out in AI. For example, how might the AI environment within Google be different from the AI environment in a startup like OpenAI?
I would I wouldn't really put OpenAI as a startup
Okay, yeah.
in terms of at least
Formerly,
the
yeah.
AI capabilities, but yeah, I do have some startup experience. At one point, I was trying to start my own, and then I've also worked for a startup in the past. I would say in terms of AI, the biggest difference between the canonical like startup experience versus like big tech experience is just the scale. At a startup, you'll probably be looking for whatever can get most of the job done rather than what gets the best job done. So for instance, like a lot of my friends and I talk about like, is it really AI under the hood for a startup? It's like a lot of them will say, we use AI for whatever problem. It's probably just linear regression or logistic regression at the end of the day, which is, it's fine. It gets you most of the way there, but it's not necessarily what's being studied right now as state of the art from a research perspective. And so I think that's really the biggest shift is the mindset is less understanding what would be the best technique to solve the problem and understanding how to improve those aspects of it, and more so just figuring out what puzzle pieces will get you most of the way there. In big tech, there's a lot more resources spent on understanding how to do things like, in a sense, perfectly. Obviously, we can't do it perfectly, but more time is spent on that.
Yeah. I'm guessing this is also partially due to the amount of money that each company has available to them as
Yeah.
well, because that would limit the scope of each project that they can work on. Or
for sure, that's a really big thing. I mean, it's really expensive to train, like for instance, large language models that like OpenAI and Google and Facebook have been releasing recently. So a lot of the times, like big tech companies have the money to be able to train their own, and then smaller companies might have to build on top of those.
yeah. By the way, you did mention that you started a startup. Could you tell me more about that and how
um,
that went?
yeah, I'll go briefly over it. It was really just a short stint, but back in my second year, I was working with actually a fellow Schulich Leader as well, but a few other folks. We were looking to start a company called Food Scrap, which was just like a one-stop shop for your food waste management was how we had viewed it, but really it was for managing like your food lifestyle. And so that was a time when I had learned a little bit about AI as well, because we were trying to build a recommender system for suggesting recipes for a person based off of like the constraint optimization being what sorts of ingredients you have in your fridge or your pantry as well.
It's quite cool. And now you said you're working currently in privacy,
Yep.
which is quite different, but it's actually really cool how AI is just so applicable in so many different industries. Could you tell me more about your research and um, how AI is, I guess, applicable within a privacy, I guess, a privacy domain or
Yeah.
security? Yeah.
Yeah, it's a really good question. In terms of like, I guess at a high level, the easy question to think is like, how does privacy and ML mix? Like, what does that really mean? The way I typically try to explain it is all of ML requires data for us to be able to do it. And in almost all cases, that data is tied to humans and individuals, and it might contain what we call like sensitive data or personally identifying information or PII. And what we study a lot in the privacy and ML literature is figuring out how we can learn like ML systems in a way that protects the privacy of individuals. And so there's a lot of like formal definitions and like theoretical and rigorous guarantees that we can provide for these systems that will protect user data. And so that's what we study there. There's also a security aspect that I study as well, and this is understanding how we can make sure that the system will work well in all the environments that we want it to work well in. For instance, a really, really popular topic nowadays is like adversarial examples in machine learning. These are inputs that look benign to a human, so they look normal to us when we look at them, but they have like minimal changes to them to make a system misclassify it. It's like the really, like the seminal work in this space explored like a panda that has like just a small amount of noise added to the image so that it still looks like a panda when a human looks at it. But when an ML system classifies it, it's now like a car or like a chimpanzee or something like completely different. And so these are sorts of the topics that we look at in the privacy and security space in machine learning.
And how long have you been working in this space for? Like ever since graduating, or?
I guess since my time with the Clever Hans lab, so I guess just over 3 years now, or around 3 years now.
Do you see yourself working within privacy for uh, the foreseeable future, or do you also have
Yeah, the
like
foreseeable future,
yeah.
yeah.
And are
Yeah.
there any other longer term interests or other areas of AI you might like to explore in the future?
Yeah, so I'd say most of my work has been in the privacy and security space, but I've also touched on some work in like the robustness literature, which is kind of similar to the adversarial example topic I brought up earlier, but it's like how can we, under arbitrary changes in the data, ensure that a system will be behaving as intended, so be robust to those inputs. And there's a lot of different models you can study this under, but that's like the general idea. And that's another area I'm interested in. More recently, I've also started doing a little bit more NLU style stuff, which has also been really interesting. That's also more tied to like the privacy side as well. But we've been studying large language models and how they like memorize data. And that's another topic area that I hope to explore a lot more. But outside of those, I would say further off that maybe will come someday are topics like optimization literature is really, really interesting to me. It's quite fascinating understanding how like the mathematical geometry of the system we're trying to learn in machine learning can be characterized and how understanding that characterization can enable us to learn better systems. So I've only done a very, very minimal amount of work in that space up until now, but I'm hopeful that maybe one day I'll be able to do a bit more.
That's actually quite fascinating. Okay, my next question is also, it's a bit more out there, but
Mm-hmm.
a lot of the work done in AI, while this is not necessarily like an explicit goal, like again, correct me if I'm wrong, but currently a lot of AI is focused on, I guess, being very good at very specific tasks.
Yeah.
But there are people who like when you say AI, for example, to someone who's not as familiar with the industry, their first thought might be something like Jarvis from Iron Man. And I was just wondering what
Mm-hmm.
your thoughts on artificial general intelligence are, and like whether you think it's like something feasible, especially since you're involved in the industry, or if you think it would look the way people imagine it to look like within fiction, or if it would be something completely different.
I think inevitably at some point we'll get there, but we're extremely far off in my opinion. I think most of like the top researchers, like if you think Jan LeCun or like Yashua Benjo, I think if you polled like those types of top researchers, most would agree that we're quite far off from that, because there are some very trivial cases where you can like see that AI just doesn't really understand. Like our ability to teach a model to generalize has been improving substantially, but is quite far from what you would need to get AGI, in my opinion. But yeah, I'd be happy to help work on that. I mean, a lot of what we do in like the privacy literature and the security literature also ties to like improving robustness and generalization, which is like what is essentially needed to get to something that it has AGI, right? Like if you think of like Jarvis, for instance, it's able to work in like new scenarios that it's never seen before and to still make like very intelligent decisions the way that a human would by applying its like prior understanding in other scenarios that might be related to that new scenario. And that's just something that we haven't figured out how to do well with AI yet, but I'm hopeful that we'll get there eventually.
Yeah, of course. And you did just mention understanding. Do you think we have any systems that exhibit a certain form of understanding within, like even like ultra specific context? Like I know, for example, I think it was over the summer, or like maybe a bit earlier than that, but I remember GPT-3 being really popular on Twitter for a while,
Mm-hmm.
and it seemed almost as though it uh, could understand certain things, but some would wonder if that was genuine understanding, if it or if it was more a simulation of understanding based on what it was trained on.
Mm. Interesting. I guess, what do you view as the difference between a simulation of understanding and true understanding?
That's a good question. Mentally, I guess like my view on this is somewhat similar to like how I view the Matrix. I don't know if you've watched the movie where I think
Yeah,
one
many
of the
times.
characters mentioned like if you can't tell the difference, like does it matter? But I honestly think it goes back to like or it goes back to how you define understanding. For example, you can teach a child to do something and they can do that.
Mm-hmm.
Like uh let's say I teach a kid how to do multiplication. This is probably not the best example, but I show them
Mm-hmm.
how to multiply within like 5 times. Let's say like multiply every number by 5. Um,
Mm-hmm.
the kid might understand how to multiply within that specific context, but then if you ask them to multiply something much more complicated, so rather than like a 2-digit number by 2-digit number, you ask them to multiply decimals with each other. They
Mm-hmm.
might not necessarily understand how to do something like that. So I think while pattern recognition is necessary for understanding, there's a little bit more to it than that because I think being able to work within a generalist context is more indicative of understanding than being very, very good at specific things because you can keep on recognizing patterns and you can keep on following those patterns again and again. But I think true understanding also necessitates that you're able to take a limited set of information and do quite a bit with it, which I think is where current AI systems don't
Mm-hmm.
shine as much.
Yeah, I think I would largely agree with that statement. From what we have right now, and at least my understanding, what we have, the AI that we've trained, I think it has very good pattern recognition abilities, and to some degree, even some understanding of core concepts. But I don't think it's learned to tie them together with logic and like learn how to compose different like core units of intelligence together to like generalize in a way that a human can. For instance, like if you learn how to multiply by 3, you should be able to like multiply by 10, 18, etc. And like all of those directly follow. I don't think it's being taught per se the first principles approach to be able to build on those core units as a human would. Now, I think we're seeing that pattern recognition has gotten so good that it's pretty easy for it to seem like it has a lot of understanding. But I think tying back to some of the earlier things that I briefly mentioned, like adversarial examples and like the security literature, it's pretty easy for us to break these systems right now. And so that, in my perspective, has prevented me from believing that they have strong understanding. If it were much more difficult to break the systems, then I could believe that they were, exhibiting a strong degree of understanding. But, if I show you a picture of what looks like a panda, then like I would have to truly change what that picture is. Like it wouldn't look like a panda anymore for someone to say that it's not a panda. But it's like pretty easy to fool a machine learning system. So there's quite a ways to go in terms of bringing us to AGI in that sense.
And do you think current approaches will eventually yield, I guess, some sort of substantial result in inducing understanding within machines, like larger models, better data, etc.? Or do you think that, again, this is more speculation than anything else, but or do you think that we would require a completely different type of approach, or a different way of looking at things to actually you induce intelligence within machines?
I think without larger models and larger data, we would never get there, but I don't think that's the solution. It's entirely possible that a simple change from our current approach would bring us there, but right now I think, like for instance, a large part of literature is focused on like scaling models larger and scaling data larger. I think it's a very, very fruitful approach, but I don't think it will solve the problem and give us AGI. We definitely need to think about how to optimize better when we have a lot more data. Think about how we can teach these models better in new frameworks so that they can really understand the data that they're like observing for us to get to a point where they'll have like human level intelligence. It might even be like we'll need a lot more better like neural network design. Like the architectures that we're specifically designing maybe aren't well tuned enough to be able to enable that style of learning is also a huge possibility. So I think, yeah, a lot of areas of literature will need to improve a lot more um, before we can see that happen. And it won't just be from scaling models larger and scaling data more.
Yeah,
I mean, actually, a sub point to that as well is part of the reason why all the big news surrounding like large models comes like once a year approximately is because it's like super expensive to train these super large models. Like I think if there's like some papers exploring like cost analysis of them, but I mean, you can imagine like the amount of data being thrown in it. Like we really are pushing the limits of what our current hardware lets us do. And when hardware gets better, then we can do more with this. But being able to do more with less is also a very important thing as well. So that's where like the better optimization comes in, is it like limits or it reduces the amount of just compute that we need to throw at a problem.
yeah. I think I agree with pretty much everything you said, given what I know, which is obviously a lot less than you, but um, yeah. Uh, I don't actually have that any more questions. Like we've already touched on pretty much all the topics I was curious about, and that's
Awesome.
kind of been running around in my brain for the past little bit. Thank you so much for your time, Chris. This was a very enjoyable conversation.
Yeah, thank you so much for your time too, Kevin. It was great chatting with you.
Yeah,
I guess the last thing I'd want to say is I think for me, research was quite daunting before I had gotten into it. But what I believe is it's really a lot easier to get into it. Like it's something that basically anyone can do if you're willing to put your mind to it and if you enjoy it. So I think the hardest part is finding someone to mentor you and to teach you the ropes when you're first getting there. And so finding that, that professor that's willing to do that is a really big thing. So yeah, if you're interested and if others are interested, I think that's the biggest first step.
yeah. Just reaching out and I guess, taking that first leap.
Yeah, exactly.
Yeah, of course. All right. Thank you very much again, Chris, for your time. This was a really great conversation, and I definitely feel a lot more motivated after listening to it. So, best of luck on all future endeavors. I'll probably reach out to you at some point, just maybe if I have more questions or yeah,
Yeah, for sure.
yeah. Thank you so much again. Have a wonderful day.
You too. Cheers, Kevin.